Hi there. We're going to discuss today um, further concepts about displaying data. So it's mostly about recording, organizing, and representing data, which called in math statistics. Um, and I thought the best way to learn it is by solving different examples, and each example or each question will represent a method of displaying data, such as in the first question, it will be about scatter graphs. And in the second question, we will have some drawn graphs, and we're going to interpret information from these drawn graphs and to answer questions. And at last, it's the back-to-back stem and leaf where we compare between two sets of data or of data. So that's what we're going to do today. So if we look here at the first example or the first question, they're giving us a table that represents the number of days or the number of exposure, the number of days of exposure to sunlight, and how does that affect the height of a plant. So as you can see from the data and that is presented in this table, they're asking here what type of graph will be useful to show the relation between the two variables, the number of days of sun or of exposure to the sun, and the height of the plant. So we're going to say that is the best method here is the scatter graph, because each scatter plot because each scatter plot is used to observe the relationship between two variables, which are in this case the number of exposure, the number of days, the number of days of exposure to the sun and the height of the plant. And how do we represent the given data on this coordinate? We actually just plot the points, such as, let me give an example here, 35 and 147. 35 represents the number of days. So we will go here and we will look for 35. So it's going to be between 34 and 36. And then we're going to draw, like, let's say, a straight line using a ruler, preferably, of course. And it's 147. So 147, it's going to be somewhere here. So this meeting point or this plotting point, it represents the 35,147. And you do the exact same thing for the rest of the points, such as 30 and 123. So you go on the x-axis to 30. So this is the 30, you draw a straight line. And then the 133, or sorry, the 123. So this is 120 and 123. It's going to be somewhere here between 120. So this will represent the 30 and the 123. And you do the exact same thing for the rest of the points, where you end up with this drawing. So you will have the following result when you plot each point that is given in the graph. And then when it comes to plotting scattered graphs, they always ask for next is to plot each point, and after that they're going to ask you to draw a line of best fit. And the line of best fit is a line. So the line of best fit is a line that will pass. Let me write this. Line of best fit is a straight line that will pass or be as close as possible to the maximum number of plotted points. So in this case, if you want to draw the line, it will be something, let's say, something like this. So this will be line of best fit. It's a straight line where, if possible, should be passing through or should be as close as possible to the plotted points, to the maximum number of the plotted points. Such as, let me just erase this and I will. So this is the scatter graph. And in order for any scatter graph to be completed, you must draw the line of best fit. And the line of best fit in this case will be as following. Okay. Okay, so this is what we call line of best fit. Which is a line that is passing through or is as near as possible to the maximum number of plotted points on the scatter graph. Okay, and what do we use this scatter graph for? So here they're asking you to use the scatter graph to predict the height of a sunflower which has had 40 days of bright sunlight. What do we do then? We go to days. So they said 42 days, and we draw a vertical line from 42 until it hits the line of best fit, and then we draw a line, a horizontal line from this point, and the answer will be around 168 centimeter. So if a plant is exposed for 42 days to sunlight, the expected height of this plant is 168 centimeter. So that's what we use so this point on the line of best fit, it's 42,168. It's just like you're plotting a point on the line of best fit, and you're finding the x and y, where the x represents the number of days of exposure to sunlight, and the y represents the height of the plant. Okay, and okay, just okay, let me just erase this and let's continue. This belongs to the first question. And here they're asking, use the graph, the scatter graph that you plotted and where you drew the line of best fit. Use this graph to predict how many days of bright sunlight a 135 centimeter tall sunflower has had. So we will go to 135 on the height, which is on the y-axis. So we go here. Let's take the pen. Let me use another color. So we will go to 135. Let's say it's somewhere here. And we will draw a straight line until we hit the line of best fit. And then we're going to grab or to draw a vertical line from this point. And the coordinates of this point is 30, 135. So if a plant is 135 centimeter tall, then most likely it has been exposed to the sunlight for 30 days. Okay? A student states this graph can be used to work out the height of any sunflower as long as we know how many days of bright sunlight it has had. Well, that is not true. Why? Because as we can see here, the graph, it started at, or the minimum point that the graph started at is 28 days, and the maximum point is 50 days, which means that only this graph can predict the height of any plant if it has been exposed to number of days between 28 and 50 only. So how can we write the answer here? We can say incorrect statement because we can only use this graph to predict the height of a sunflower which has had been exposed to sunlight at least for 28 days and maximum of 50 days. Okay, so that's all about scatter graphs. So all what you need to know about scatter graphs is data is given to you in terms of two variables, and one of the variables is represented on the x-axis, the other one is represented on the y-axis, and you display the data by plotting points, just as we used to do in straight line graphs or in drawing straight line graphs. And once you're done, you need to draw the line of best fit, which is a line that will pass through the maximum number of plotted points, or as near as possible to the maximum number of plotted points. And from this graph, we can answer many questions that is related to the two variables that you represented on the x and y axis. The next thing that we're going to discuss in this record is interpreting data from drawn graphs, such as in this question here. So we have species Q and species P, okay? And as you can see, there is a drawn graph for species Q and species P, which tells the relation between frequency and the length of species. So by looking at the characteristics of both graphs, decide which species has the larger mean length. And as you can see here, they said that this is M2 and this is M1. And as we can see that M1 is taller than M2, so accordingly, the answer for answer A will be as following. Species P has a larger mean length. Because if you compare the length of M1 and the length of M2, we can see the difference in length. You can see the difference in length. And let's go to the second question. Which species has lengths which are within a smaller range? As you can see, species B as well, or species P as well, if you look here, you can see that the graph is spread out, that the distribution is not spread out, while here in species Q, the distribution is more spread out. So that tells us that species P has less or has a smaller range. So the answer is, again, species P has lengths within a smaller range because its distribution is less spread out than species Q. If we go to the second or to the third question of interpreting drawn graphs, this another snake is caught and its length is measured. Its length is X, as you can see here. This is the X, okay? Its length is X, and okay, as shown on the graph, is this snake more likely to be from species P or from species Q? And justify your answer. Now, if you draw, let's say a line, a vertical line from X, and it will hit the graph of species Q here, while if you continue from X to the dotted graph of species Q, and as you can see the difference of the height, we can say that snake X is most likely from species P. So the answer here is snake X is mostly from species P, because only few number of snakes that have this length occurred in species Q. As you can see here, the frequency here is way less than the frequency here. So most likely that a snake with this length would be from species Q rather than from species P rather than from species Q. So I will continue here to explain. As frequency indicated on the drawn graph. So that's how we interpret answers or data from drawn graphs. Last thing that we are going to discuss in this record is the stem and leaf, and stem and leaf are really useful in comparing two sets of data, such as in this question, the back-to-back stem and leaf diagram shows the heights of 20 tomato plants. 10 of them were growing outside and the other 10 were growing in greenhouse. Okay. So how do we know that it is perfectly 10 and 10 in A and B? You just go and you count the numbers here. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 data in A, and here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 data in B. Okay. And as we learned earlier, what we need or what we look for in any method of representing data is the range, the median, the mode, as well as the mean. And now we are going to learn how do we calculate this here in the back-to-back stem and leaf, which represents 10 data in A and 10 data in B. The difference between them, one of them represents tomato, which were growing outside, and the other one represents tomato, which were growing in greenhouse. How do we read each number? For example, if you take the 8 here, from A, it will be 18. So this represents the tens, and this represents the ones. So this represents the ones. How do we read the 3 in B? It will be 13. How do we read the 4 in A? Here, the 4, it will be 34. How do we read the 5 in B here? It will be 35. So the key here, 7 to 1. So it will be 27 for A, while it will be 21 in B. Why is the stem and leaf a useful way? Why is it a useful way to display data? It is, I'm going to answer this here. It is useful to compare two sets of data, such as 10 tomatoes were growing out in comparison to 10 tomatoes were growing in green house. So it is good to compare two data using the back-to-back stem and leaf. Okay. Compare the distribution of results from both groups of tomato plants, commenting on any similarities and or differences. As I explained earlier, it's not any different from any other statistics. What we are looking for here is the range, the mode, and the median, as well as the mean. How do we calculate this in the back-to-back stem and leaf? Okay. In order to calculate the range, we need to find the greatest, the smallest number, as well as the greatest number. So if we go here to A, for example, we will find that the smallest number is 18. So, and please note that the numbers are always organized from the smallest to the greatest. So 18, 19, 27, 27, 28, 33, 34, 35, 42, and 46. So in A, it's right A here, we're going to say that the range is equal to the smallest data is 18, while the greatest data is 46. So 46 minus 18, the difference between the smallest and the greatest data is 28. Let's do the exact same thing for B. So as you can see that the data is organized from the smallest to the greatest, 12, 13, 16, 21, 22, 22, 34, 35, 35, and 40. So in B, the range is equal to the greatest number is 40 minus the smallest data is 12. So 40 minus 12 is 28. And as you can see here that the range is equal in both A and B. Now let's calculate the mode, the most repetitive data. So 18, 19, 27, 27. As you can see here, we can see that the 27 has been repeated twice. 28, 33, 34, 35, 42. So 27 is the mode frequency of 2. It has been repeated twice. Let's go to B. 12, 13, 16, 21, 22, 22. So we can see that it has been repeated twice. And 34, 35, 35. Is it possible to have two modes? Yes, it is possible. So the mode here is equal to 22 and 35. Okay. We also need to calculate the median. Median is finding the middle number. So median. And when we counted the data in A, when we first started with the question, we found that A has 10 data. So it's an even number. So for the median, we're going to end up with two numbers in the middle. How do we find the median? You cross the smallest and then the greatest. So you start by crossing the smallest data and the greatest data. The smallest, the greatest. So 18 with 46, 19 with 42, and here 27 with not 33, not 34, with 35. And then so 18 with 46, 18, '19 with 42, and then 27. Okay, and here again 27, the smallest, with 34. So what do we have left here? So we have left here the 28 plus the 33 divided by 2. So if we end up with, if we have an even number of data, we're going to end up with two middle numbers and we find the average of these two middle numbers, and it will be here 30.5. Let's apply the exact same thing for group B. So group B, as we explained earlier, it has also a 10 displayed data. And so we're going to end up with two numbers in the middle. We start by crossing out the smallest number, which is 12, and the greatest number, which is 40. The smallest number, which is 13 now, and the greatest number is the 35. 16 is the smallest now, with the greatest, which is 35. And the smallest here is 21 now, with the greatest here, which is 34. So we're going to end up with these two numbers. So the median here is equal to 22 plus 22 over 22, and the answer will be 22. And as you can see, that the median here is in A is greater than the median in B, is greater than the median in B. We have the last thing to calculate, so I'm going to scroll down here and I will calculate the mean for each here, down here, okay? So we have A, so the mean is equal to fraction line. So the first data here is 18 plus 19 plus 27. It has been repeated twice, so it will be 2 times 27 plus 28 plus 33 plus 34 plus 35 plus 42 plus 46, all divided by the number of data as we explained earlier, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So all divided by 10. You insert this in the calculator and you find the mean. We do the exact same thing for B, fraction line. So we're going to start. Okay, so it's 12 plus 13 plus 16. So that's the first row, plus 13 plus 16. And then 21 plus 21. And as you can see here, 22 has been repeated twice, so it will be plus 2 times 22 plus 34 plus, as you can see, 35 has been repeated twice, so it's 2 times 35 plus 40. And the number of data, if you count them here, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the number of data is 10. And that's how you find the mean. And based on calculating the range, mode, median, and mean, you can answer the questions. So here they're asking you, compare the distribution of results from both groups of tomato plants, commenting on any similarities. So after you find them, you can answer here that the range is equal. So you can say that the range of A and B are equal. And if you scroll down, which groups of A or B do you think were the plants growing in the greenhouse? give a convincing. Most probably it's group A. And why? Because as you can see that the averages for A, the median was greater. So we're going to say the answer here, group A is or includes the plants growing in greenhouse because the plants are on average taller as shown from the calculations of the mode median and mean. And that's it for today. I hope you found this record useful. Please do watch it as many times as you need to until you nail the concepts of scatter graphs, interpreting data from drone graphs, as well as the back-to-back stem and leaf. Thank you, and I will see you in the next record sometime soon.